first year PhD student doing on Western Sydney University under the supervision of Professor Jeff Powell and co-supervised by Dr. Jason, Dr. Sherai, and Professor Bernadette McAvey. So at the end, all of us, we are discussing to make it commercialized or the nutrients available to the fertilizer level. So there, here I am going to show what I found after using the Urval at the end user. So today I'll be discussing the fertilizer, the one Urval we are using, what challenges we can see in the agriculture level. So for that, I wanted to go a little background on, as we all trying to give some nutrients or agriculture support in the form of balanced nutrient or nutrient fertilizer. As we all know that NPK is much important in the agriculture system. Apart from that, micronutrients and water, carbon and everything is really important. But in case or scenario when these nutrients are not balanced, there can be so many issues regarding the deficiency or excess. So these nutrients or fertilizer have to be always balanced to have a healthy crops or healthy soil. In the sense, if this can go deficiency or excess, we can have so many toxic problem, salinity issue relating to the future. Sustainability will be not in our hand. So just taking consideration with this information, I wanted to give you a little background, as we all are soil or chemistry background. As we can see that most of the recent literature or the fertilizer, if we can see and have a look on that, we can see from this picture as well that most of the nitrogen fertilizer, they undergo with different process or the different steps in the soil system. Nitrification, ammonification, oxidation. Overall, there is a release of hydrogen ion. When this hydrogen ion is not balanced or not equivalent to the hydroxide, there lead to be a soil acidification, which means a big issue in the context of Australian soil, where there is a lot of soil, acidic soil. So there is soil acidification, which means I'm going to connect with you. Soil acidification relate to the soil pH. As we all know that whatever we are giving nutrients to the soil, if the nutrients or the soil system is not in the good pH, that means the neutral, the availability of the nutrients will be not adequate to the plants. As we can see that most of the available nutrients comes on the neutral range, 6 to 7.5. So let's take one more step closer to the phosphorus. As we can see that phosphorus is also always a limiting factor to the crops. The optimal range for the phosphorus is always 6 to 7. And always the phosphorus is available to the plant in the diphosphate or hydrogen phosphate ion in the form. But if the soil pH goes below or above this neutral level, there is a problem. Suppose phosphorus can be bounded by other chemical compounds, or if goes above the alkaline. But not only this issue, if the soil pH comes down to the neutral level, it can release oxide metals, which can be toxic to the plants and crops. So while I am discussing too much pH things, I will take you there. Why I'm trying to make you more consideration with this pH, because this pH is associated with the Urval product, which I am going to understand and see the behavior of this product in the field level. So where we are all aware that Urval is rich in high nutrients and all, but there is a concern regarding the high ionic strength. That means highly dissolved ions in the product. That means 10x time to the comparing to the mineral fertilizer we are using, and the pH is very low. That is 3.3, which is one of the concerning things which I have to consider while doing my experiment. For that, I try to understand what will be the adequate dose with this issue, this concern, if I am going to use in the field level. So for that, I wanted to optimize the dose from this experiment, where I have to choose the two pasture crops, two pasture crops, and I try to use in the different nitrogen doses, and I hypothesize that the Urval will be good with the adequate amount, not with the high dose. There might be the toxicity symptoms with Urval. So for that, I designed experiment at the Hawkesbury campus, Western Sydney, with the two different pasture crops, taking two different fertilizer, comparing Urval with the mineral fertilizer. Equivalent to the Urval fertilizer, I care only NPK and give the exact amount of NPK with the Urval. and with two different nitrogen dose, 100 kg nitrogen per hectare ratio and the 200 kg nitrogen per hectare ratio. Taking this consideration and reference from the grassland pasture reference given by the UK. This is how my pot experiment looks like. So for this experiment or this instance, I was really interested just to see the Urval with the plant response, where I have checked shoot and root biomass, chlorophyll content, change in the soil pH and EC, and also with the nutrients on the plants and both soil analysis. So after the fertilizer, almost 90 days after giving the experiment, which I am showing this picture because first two picture you can see that mineral fertilizer and Urval with the 100 kg, it looks very good, healthy, green, and that makes sense. But when we went looking the down picture, 200 kg nitrogen per hectare, the left one with the mineral fertilizer, the right one is with the Urval. Mineral fertilizer, plants still looks good, healthy, and easily accessible, but with the Urval, all the plant were died, looks like highly toxic for this plant with this Urval. So I go more closer to that to understand now. Mineral fertilizer is okay, but Urval is not okay. So what is the reason? So I try to analyze some result. So from the plant biomass, I have found that this is the shoot biomass results after the fertilizing 30 days, where you can see the leucine and phalaris data I'm showing. So leucine and phalaris, two different kind of species. I will not discuss a lot about that, but what I have found with the Urval and mineral fertilizer here, with the leucine, there is no significant difference in between any fertilizer type or any doses. But with the phalaris responds very good with the Urval, leading to high biomass and high yields. But the same scenario after the 90 days, the one picture I showed you before, with the leucine, mineral fertilizer and commercial fertilizer is still at the 100 kg nitrogen per hectare. Result shows very good and healthy plant biomass. But for the leucine, you can see at the 200 kg nitrogen dose, there is nothing remains, no biomass remains, but still with the phalaris 200 kg Urval decrease the biomass, but mineral fertilizer still looks more healthier at the high dose itself. So this shows that there is something happening with the Urval, because all the nitrogen, phosphorus, and potassium concentration equivalent to the mineral fertilizer, still there is toxicity happening with the Urval and the leucine. So I go one step more inside to just to check the chlorophyll content, how this fertilizer behaving with the plant species, where I have found that Urval is again really behaving very well with both the plant types and showing that high nitrogen uptake, easy available nitrogen for both the plants. And also I have seen that with the Urval treated plant, we have seen aphids were seated on the plants. That means nitrogen is available, easily available with the Urval, but not with the mineral fertilizer. But overall, that nitrogen content was good for both of the plants treated. So again, just to understand, I'm trying to understand what might be the toxicity or the mortality issue. So I went more inside with the soil things to understand how this Urval is behaving with the soil properties. Just I try to check regular. Sorry.
Stop it. Stop your prediction. Yeah. Cannot say the name of Urval.
Yeah. Too dangerous. Hoaxing and then upbeat. Too much, you know.
So I think everyone wants to see, yeah? Should I stop? Okay. Yeah, so just to see the how this soil pH, as I already recall the back soil Urval pH was very low. That makes sense because pH decreases with the doses of high nitrogen doses, where we can see that from the both mineral fertilizer and Urval fertilizer, there is decline in the pH for both of them, for leucine plants and the phalaris plant as well, but not small amount. Within 90 days of per trial experiment, we have the decline of 1.2 unit of pH. There is almost like from 5.8 to 4.6 unit it decrease. There is might be the release of heavy metal and toxicity. But also I was considering there might be high ionic strength that can change the EC. But with that short time, we haven't seen any significant difference in the EC. That's very good for us. So overall, just trying to conclude, and other result I will show in later, or maybe in paper you guys will see. So concluding and discussing what I understand, that with the adequate and moderate dose, we have very good healthy biomass with the Urval. But with the high dose is plant mortality and toxicity, very good chlorophyll content on the plant, high nutrient availability, but the soil acidity issues. Considering these issues, I plan to have my another experiment. As we can see that Lucerne at 200 kg and the Phalaris at 200 kg was not happy, and the 100 was happy. So I have planned to split more doses. So I'm doing another experiment to understand both from plant and soil perspective. I have different 7 doses and try to understand what will be the adequate and suitable dose for these 2 plant specific. So from this experiment, I will give at least this much dose we can give, which will be very good for our plants. Thank you, everyone. Thank you, Niraj, and
And if you turn that on, it will take some time to. Very good. Yeah.